Hello friends, welcome to Susan and John MathTube. So this is revision with past paper questions. So in this video, we are going to start discussing about a topic which contains 15 to 20 marks. Normally it will be for 20 marks, but now and then it will be like 15 marks. Okay, and the topic is testing of hypothesis. Okay, once more let me make it very clear. My aim in these revision videos is just to discuss, it is a casual discussion about the question paper. So the first thing you have to do is, I have made many videos in testing of hypothesis, and if you do not know that subject, first of all, learn the 7 different testing methods that is mentioned in your syllabus. You can search for the videos or I'll put it in the description and in the comment section also. You can find the videos related to testing of hypothesis. First of all, watch them, make the subject clear and then only come for revision. Okay, so the first question I have right in front of me. Okay, we are given 5 measurement of tar. Okay, so someone has broken a cigarette down and they are measuring the amount of tar that cigarette contains. And they have the amounts here in milligram, and what I see is it is a small sample. And the manufacturer's claim is, okay, so the proposed value, the claim by the manufacturer is, so what is our null hypothesis? Mu is equal to 14 milligram. Show that the difference between mean and the manufacturer's claim. So what is the alternative hypothesis? Always remember, alternative hypothesis is the objective to whatever we are trying to do with the help of samples. Whatever we are trying to prove with the help of sample will be called the alternative hypothesis. Is significant. So they want to check whether the manufacturer's claim is matching or mismatching. So basically it is not equal to 14. So you have to understand a few things. By looking at the alternative, I can understand that this is a two-tailed test. And by looking at the sample size, I find that it is small sample test. And another thing I want to add is, when you go for level of significance, write alpha, then alpha by 2. And the last thing I want to remind you is, the tabulated value, the t tabulated value will be t, alpha by 2, comma, degree of freedom. Degree of freedom will be n minus 1. Okay, try this problem. Okay, another question is here. At what condition should we use the paired t-test? They have not given some of the questions very clearly, so use a few assumptions and your imagination, because I saw a few mistakes here and there also. Anyway, what is the condition to use paired t-test? Write the procedure of writing paired t-test. Okay, so you can check that video. I'll put it in the description, paired t-test. So I'll give you a rough idea here. So look at this. Now and then we might have to compare the before and after events. For example, the before performance and the after performance of some engines after some modification. You know, all the automobile manufacturers will produce one vehicle in the beginning. Normally they will call it version 1 or Mark 1 or Ace 1 or whatever related to the first version. And then what they do is, there will be some sort of mistakes here, they will improve it. Or they claim that they improve it and they produce the next version. So someone wants to test whether there is some sort of difference between before and after. Okay, ideal case to apply. Now look at this. In your examination, when you write what is the condition, make sure you give some examples also. Be creative and give some examples, so that you can be sure that you get that 5 marks or whatever be the promised marks. Okay, Now another thing, yeah, okay, another example. Let's say in a statistics class, what I did is I asked the students to write a surprise exam. I wanted to know how good my students were. And then what I told them is, okay, you go home, you prepare, and I'll take a retest next week. So again, after 1 week, they gave an exam. Now look at this. I want to know whether there is any difference between the previous performance and the current performance. Okay, that's the best place to apply paired t-test. Anyway, the procedure is there. You can write the procedure also. Okay, now they have asked, what do you think? Is it ANOVA or is it? I see the word independent. Okay, so I know they are going to do chi-square test of association, independence, test of independence. It's pretty small, so we can do it easily. Do you remember how to do chi-squared? I have kept some videos for chi-squared. You can check it. This one is different from the video I have kept, because the video I have kept, there were more rows. Here there are only 2 rows and 2 columns, right? So let's do it together. I'll give a rough idea. Please make sure you double check the calculations. I'm going to do it very fast. So we have the contingency table. Okay, what is step number 1? Step number 1 in chi-square is H naught. The parameters are independent, and the parameters are patient category and the care that they get. So the parameters patient category and Medicare are independent, and H1 will be not independent. And step number 2, level of significance, it is already given. And in chi-square and ANOVA, you never have to worry whether you have to take alpha or alpha by 2. It will be always alpha. Check the videos in chi-square. I will keep it in the description. Patient category, and here I will write Medicare. And there are 2 options here, yes, no. Okay, and then I think you remember what to do here. We will write the column total here and the row total here. And here I can see there are 2 categories, surgical and medical. Okay, so I'm going to divide every cell, you know this cell, right, into 2 parts. If you look at the previous video, I might have done little bit differently. Maybe the cell design is different or the method might be different, but basically we are talking about the same thing. Okay, so what is the observed value? I'm going to write the observed value here. Observed value, observed value, observed value. So what are the observed value? 620, 380, 550, 450. And what are the expected values? Do you remember the formula to find expected value? Row total, column total divided by grand total. So we go for the row total now. 620 plus 380, that is obvious, 1000, 520, so that will be 1170 and 830. Double calculate, I am doing it a bit fast. So the total is 2000. So the grand total is here, grand total is 2000. Now how do you find the expected for the first cell? Row total multiplied by grand total divided by, row total multiplied by column total divided by grand total. Do the calculations yourself. Anyway, I think my answers are correct. I got 585. Row total multiplied by column total divided by grand total 415. 585, 415. These values can be different, depends on problem to problem. We got the same answer here, that's why the same answers. Okay, now how do you find chi-squared? Do you remember? Summation O minus E the whole squared, the whole divided by E. Remember, this square has nothing to do with the denominator. Anyway, I got the calculated value of chi-square to be 10.09. Check whether this answer is correct. And you know how to do O minus C, right? 620 minus, I'll give one example, 620 minus 585 whole squared, the whole divided by 585. Like that, like that, like that, like that. Add them up, you'll get this. And then what is step number 4? This is step number 3, by the way. Step number 4 is tabulated value. And I hope you remember the rules for chi-squared. In chi-squared test of independence, the degree of freedom is number of rows minus 1, number of column minus 1 in the question, degree of freedom. And that will be 2 minus 1, 2 minus 1. What is 2 minus 1 into 2 minus 1? That will be 1 into 1, 1. Sorry, that is the degree of freedom. And what is alpha? Alpha means significance, 0.01. You can check the tabled value. They will give you the tables, or the table values will be provided. I got this value. Now in step number 4 itself, you have to make a graph. And the graph of chi-squared is like this. And you mark the tabulated value. And where will you write reject? On the tail. And accept here. So clearly this value. Now decision, step number 5, decision. The calculated value is in the rejection zone, right? So reject H0. That means they are associated. That means there is some sort of relation between these two. So basically my conclusion is reject H0. Look at this. When you go for examination, you have to follow 2 things. Never stay whole night and prepare the day before exam. You need sleep. Because presence of mind is very, very important. Especially when there are like what you call small typing mistakes in the question paper. That will create a huge anxiety for the students in examination time. And second thing, your presence of mind is very, very important when you write an exam, especially a math exam or a numerical exam. Okay, so a builder claims that heat pumps are installed in 70% of the homes. Would you agree with this claim if a survey of new homes in the city shows that 8 out of 15, look at this, 8 out of 15, 70%, etc., that tells me they are talking about single proportion. So look at this, what is the claim by the builder? What is the claim by the builder? Yeah, the proportion is 70, that means 70 out of 100. So this is the population proportion according to the builder. Then someone took a random survey and they surveyed 15 houses. So P hat, the sample proportion, in some books they write PS. The sample proportion is 8 out of 15. And what are we trying to prove? Will you agree with the claim? So basically we have to prove that whether the claim is correct or not. So equal or not equal to. So that means it is a two-tailed test. It is a two-tailed test. Okay, that's it. You have to use the test of proportion. Okay, let's go for another question paper. In this question paper, the first question that I see is the mean consumption of food grains among 400 sampled middle class consumers is 380 per gram, etc., etc., etc. Can you justify that? The classes. So they are telling there are 2 different classes. That sounds a little bit weird. Middle class and working class. I used to think middle class people also used to work. Yeah, okay, let it be. So they're talking there are 2 categories, middle class and working class. And can you justify both? Okay, that's very clear. So the null hypothesis is both of them consume the same stuff, and alternative is not equal to. Again a two-tailed test, and it is large sample because 400 and 380 means you go for large sample test. And another question is here. I like this question. Provided your theory part is in very good condition, write down the necessary steps for testing of hypothesis. You can pause this video and check the testing steps I explained in another video, or you can search in Google, or you can take any statistics book that you like and go for it. Now the next thing, ANOVA. Okay, so I'll put the link in the description. I have kept a video for ANOVA. And remember, you have to practice many questions in ANOVA, because in most of the question papers you'll be able to see ANOVA or chi-squared. I'll put one more video as a follow-up of this, because sometimes they ask different questions. Especially I'll keep a separate video for this, because this is the first question paper in which I saw this question. So look at this. In your syllabus you have chi-squared test, and remember, chi-squared test can be used for test of proportion, and it can be used for test of independence. We did one problem just now, right? Test of independence. And there is one more thing that is called goodness of fit. Okay, so I'll put one separate video for goodness of fit just as the next video. So we won't be discussing this here. Normally they never used to ask goodness of fit. The most repeated question in chi-squared used to be testing of independence of attributes. So this is a good lesson that you should never skip any topic given in the syllabus. Okay, now confidence interval. Okay, so basically I see that there are only 3 questions here. 3 questions. So this is a 15 mark, and the next question is confidence interval. It's not testing. Okay, again this is another question paper. So you can see that it is ANOVA. But wait a minute. It is nowhere specified it is ANOVA. By the way, by just looking at this question and watching the video will not help. You have to pause the video, check whether you are capable of doing and getting the answer. There is significance indicator difference. Okay, what does ANOVA do? ANOVA simply checks whether the means are equal or not. So we will be able to find whether the population mean for all these data are the same, or if some of them are different or not. Not all are equal. So by that way you have to understand this is for ANOVA, because in examination you should not get confused whether it is ANOVA or chi-squared. Now the second question depends on how good you are in testing of hypothesis, procedure, theory part. Okay, now this question paper is really good. I like this question paper. Look, ANOVA question and chi-squared question. How do you know it's chi-squared? Look at this. Is there any association, is there any relation between the region and the purchase brand? So they are asking test of whether these are related or not. Once more I am telling you, please watch the video on how to work out chi-squared distribution for independence of attributes. So again, only 3 questions I guess. Yeah. So the 4th question is confidence interval. Okay, now let's look at another question paper. Okay, so look at this question number 12, ANOVA. Now I don't want to waste your time, so I'm not going to discuss too much. This question is very important, because I've seen this question repeating many times. Okay, so look at this. A civil engineer claimed that the volume of beams are greater than 10 feet. So he's like the manufacturer. He's giving the proposed value. So that will be the null hypothesis. So the null hypothesis tells you volume of the beam is greater than 10, and test whether his claims, so of course the alternative will be less than or equal to 10. So this is left tailed. Now another bad news here is you have to calculate x bar and sample standard deviation. I'm warning you, calculate sample standard deviation from this data by yourself. And is it small sample or large sample? 1 2 3 4 5 15 small sample. So this is small sample. Small sample means t distribution. Okay, so next one. By the way, this question is also very important. I have seen this question being repeated many times. I kept a video for proportion. You will see the same question or similar question in that. Okay, so this is about proportion, single proportion. You can check the video, single proportion. And once more I am repeating, please make sure you work out a lot of questions. Now this is interesting. So tell me, ANOVA or chi-squared? Come on, tell me please, ANOVA or chi-squared? No, not ANOVA, because they are asking whether there is any relationship. Is there any connection between the gender and nature of work? So it is chi-squared. Chi-squared, test of independence. Once more, let me tell you, there are three things: chi-square test of proportion, chi-square test of independence, and chi-square goodness of fit. The next video will be about goodness of fit, because previously I never kept a video for goodness of fit, and just now I saw that they asked goodness of fit. So let's go for one or two more question papers and wind up this video. And along watching this video, I hope you're pausing the video and working out these problems. Yeah, okay, so look at this. So can you understand how important the theory part is? Look, but the problem is you cannot predict anything. Literally now and then they're asking theory questions. So that's a weird thing. I think using probability and statistics you'll be able to predict such things. Okay, now this is clearly ANOVA they have mentioned. See, the same question, that ABC company, same question. So single proportion. Wow, now two theory questions. So basically this is chi-square test of independence. Now let's go for one more question paper. Okay, so here I saw something a little bit weird, because it's basically two mean testing, and even they have given the hypothesis, null hypothesis, everything. But the sample size, look at this, one is small and one is large, but they have mentioned one very important thing, that normal population, the samples come from normal population. And whenever they mention this, I'm sure that you can use large sample test. So basically that small sample size will be taken as large sample test. Yeah, and another very important thing is, like, they will ask the possible error in testing of hypothesis. So make sure you write that or study that theory part. And they're asking what is the difference between Z test and T test. And another proportion. Okay, I'll give a small hint for this. So look at this. A real estate agent claims that 60% of the buildings, the private buildings, have 3 bedrooms. Okay, so he's like the manufacturer. He's giving the proposed value. So the null hypothesis will be P is equal to 60 out of 100. And to test this claim, we are using the samples. So the alternative will be P not equal to 60%, because he never said that there will be at least 3 bedrooms. If he says like that, we have to use greater than or equal to. And if he says at most, we have to use less than or equal to, etc., etc. So this is a two-tailed test. So that's it. The next video, we will come back with chi-squared goodness of fit, because in one question paper I saw that, and that's the first time I saw they ask chi-squared test goodness of fit. Maybe in other question papers it might be there. So it is better that we study chi-square goodness of fit. So till then, bye.